Hey, welcome back to class. It's Bram Duffee here to talk more about research. And today we're going to talk about experimental design, which is how experimental research takes form. It's a fundamental approach that's used to establish and how to figure out how we're going to work out our causal relationships between variables. So one way to look at this is how are we going to figure out what's going on? And so imagine that you're a scientist or a farmer, right? And as a scientist, you are looking to figure out why certain plants grow better in certain different conditions. So you could put together an experiment where you would be able to identify what kinds of factors were that directly influence that growth, because you would be able to measure and evaluate and look at the things like sunlight or water or temperature or nutrients, right? So these kinds of things would be able to be factors. So the primary reason for conducting experimental research is to uncover these kinds of causal kinds of connections. So to make a causal claim, you need to manipulate an independent variable and observe any resulting changes in a dependent variable. So for instance, you want to prove that sunlight affects plant growth. You would alter the amount of sunlight a plant receives. And that sunlight a plant receives is the independent variable. And then you could measure the growth, and the growth would be the dependent variable. So that's how you would be able to make a causal claim in a way that manipulates the independent variable and observes the resulting changes in the dependent variable. And in this case, again, the sunlight a plant receives would be the independent variable, and then measuring the growth, that happens is the dependent variable. So preparing for an experiment involves deciding if this method that you're working with is going to fit your research question, especially if you're focusing on cause and effect kinds of relationships. So you want to maybe consider an experiment where you would hypothesize that exercise improves mental health. So for something like that, you would first define the key variables. And so you have exercise as the independent variable and mental health indicators as the dependent variable. And then check for any potential intervening factors that might influence the results. There are different ways to conduct experiments, like through surveys or observations, but reviewing past research can guide your method choice. So imagine reading studies where exercise routines were monitored through self-reports. And that might help you decide on how you would track your participants' activities. Experiments designs vary, and control is really what is central to making sure that you have an effective manipulation of the independent variable. So consider a study on a new teacher's method and how that teacher's method impacts student performance. You divide students into groups, with some experiencing the new method, and then others would follow the traditional approach. And this comparison helps determine any observed differences in the performance that are due to teaching itself there. The control group play a vital role in experiments. They serve as a benchmark, allowing researchers to compare outcomes against those who didn't receive the experimental treatment. This helps confirm whether the changes in the experimental group stem from the intervention or if they have other factors that might help explain. So if we think about how other things play into this, I want to mention that randomization is something that really strengthens experimental design by reducing bias. Because if things are random, randomly assigned, you're setting yourself up to have things work so that you are ensuring that each participant has an equal chance of receiving any kind of effect. And what happens then is you end up balancing the individual differences across the groups. Replication is critical, right, in an experimental kind of research. And so by repeating the experiment multiple times, you can verify that the results are consistent and not due to random chance. So suppose that you find that something really seems to come to light and be self-replicating. If you can show that you have information that keeps coming to light, it helps show that there's some reliability and that information is not a fluke. But experiments do face some potential biases and threats to validity, right? Because there are time-related factors, like participants that might drop out or become aware of the study's purpose. That kind of stuff can skew the results. Consider a long-term study on diet changes, right? Like participants might naturally become healthier over time, affecting the outcomes. And so these kinds of things happen. And so altogether, experimental design is a systematic approach that allows researchers to establish the whole cause and effect relationships through controlled conditions and the manipulation of variables. And I think that it's interesting because these kinds of things are highly criticized when we look at elements of human behavior. Because when we have elements of human behavior, the choice or the decision or the outcome can change based on all kinds of factors, and that's what we're talking about, are these different aspects. And so if we think about variables, then we have to also think about the fact that if we're conducting a human study, then that person might be frustrated or hungry or tired, or any number of kinds of things can affect it. So its significance lies in providing a structured framework for how we can make different factors interact. And this is what enables researchers to make robust and reliable conclusions about the effects of their efforts. So when we talk about experimental design, we understand that the cause and effect relationships are much more common in scientific research. And it's much more difficult to find those same cause and effect relationships in the same way, with the same level of reproducibility with qualitative research. And so in qualitative research, we look at those factors and take into account those mitigating forces. And so in all, I think that thinking about how a experiment is designed based on the fact that we have pieces that we can manipulate and move, and we have aspects that stay the same, and comparisons that might be able to be made. And so right now, that's what we have for experimental design. I look forward to talking to you more and seeing more about this with your writing soon.